day, my amazing disciples. It's your favorite sensei here again, Sensei Mahal. And on today's lesson, we are gonna be dealing with arithmetic sequences. Yeah, we are gonna be dealing with that. I know, yes, to some of your metrics, it may be revision from grade 11, but yeah, we're just gonna be dealing with that. Just a few complex examples and few explanations here and there, and then we'll be done for today. So if you are new to our channel, please make sure right now press the subscribe button down there and also that notification bell so that whenever we post new lessons, you will be updated and you won't miss out on all the fun. né? So let's get straight into it. So arithmetic sequences, to some of you all, yes, you may be familiar with that. So what are these arithmetic sequences? In a way, you can usually say arithmetic sequences are more or less like the basic normal patterns that we are used to it. Basic number patterns that we are used to. In a way, it's more or less like that. So but then here things are not really the same as the way we usually used to do it. You still remember in the last video tackling that exam question, there was this kind of thing, TP MP plus Q. So they told you that in that video they were saying that we should try to find an equation in this format. So remember, in this format we basically using the old way of like m is more or less like the gradient or the constant difference, stuff like that. So here it will be just simple changes, but then it just won't be that hard to use this type of formula. So this is the general formula that we usually use whenever we are looking for the general formula or the general term of the arithmetic sequences. So, and these two are the formulas that we're gonna use whenever we are finding the sum of the types in the arithmetic sequences. So please note, this only applies to arithmetic sequences only. Geometric sequences, quadratic sequences, you don't use this one. né? So please make sure. So A stands for the first number in the original sequence. D is the constant term, and N is for the number of terms in the sequences. Let's say you're looking for T11, you know what it's going to be. T11 equals to A plus 11 minus 1 and the difference. né? So L here. L stands for the last term in the sequence. So whenever, in most cases, they may give you a term, let's say they say 1, 2, 3, 4, 5, and the last term in the sequence is 10. So you all know that the first term in the sequence A is 1 and 10 is the last term in the sequence. So basically you can use this to find the sum of all the terms in the sequences. né? So this one, you only use it whenever you are given the last term in the sequence. If they say find the number of the first 6 terms, you can see it's the first 6 terms is 1, 2, 3, 4, 5, and 6. né? So you know that it's gonna be 1 plus 2 plus 3 plus 4 plus 5 plus 6. 6 here, it's not the last term in the sequence, so you cannot use this one. You basically have to use this one. So it's more or less the same thing, but today I don't want us to deal with this thing. I just want us to deal with a few complex examples when dealing with arithmetic sequences. né? So let's just erase that and get straight into doing the work. So example number 1, we are given an arithmetic sequence here. So the first term is plus 3 plus 7 plus 11 plus 15, then dot till the 100th term. So now you know that all these terms differ like 100. So you know that it's term number 1 till term number 100. So you know that the sequence has 100 terms. Ne? So first question says find the term. You can try to pause the video. Just try to do simple revision work. Try practicing it and see if whether you really are good in this arithmetic sequences or not. So just use that as like introspection, just to check Nyana. So you can try to pause the video, try doing them, and then unpause the video. Ne? So the first term in the sequence here is 3. So the first term is 3. The constant difference here, okay, even though it's in the second question, I'm just gonna do it. So from 3 to 7, we know that we add 4. From 7 to 11, we add 4. So basically, we know that we add 4, 4, 4, 4, 4. So definitely, we found the second question. So from 11 is the third term. The fourth term is T50. So the fifth term will be fifth term plus 4 is 19, and the sixth term it's 23. Let me just use a different color here. Let's just use yellow. T6 it's equals to 23 plus 23. Ne? So the constant difference we found 4. Ne? So this is just a warm up. So let's do other questions. So find the general formula of the sequence. General formula is more or less like the general term. So we knew that from the previous questions that A is equals to 3 and our constant term is equals to 4. So let's try factorizing here. So it's 4 multiplied by n, it's 4n minus 4 plus 3. So this are like terms. So it's 4n minus 1. So this is the general formula. Ne? So now, most usually we can try using this whenever we're looking for other formulas. So in most cases they might give something like this. So we know now for whenever T1 is equals to A, T2 is equals to A plus n minus 1 D. Ne? So I'm not gonna use this. I just want to show you a simple trick of how you can try solving for A and D and stuff like that. Ne? So we know that T2 is A plus 2 minus 1 D, and here it's gonna be A plus 1 D. So now T2. So T3 is gonna be A plus 2D. T4 A plus 3D. So it's more or less like that. So if now we know that we looking for T15 here, we can just basically use this. T15, oh sorry, T4, sorry, it's equals to A plus 3D. So if you know it's 15 and or let's say, okay, it's 15, we know that it's 3. Let's just prove that it's gonna give us the correct thing here. So it's 3 plus 3 into 4. So it's gonna be 12 plus 3. So most definitely it just takes us to the very same answer. Even if we can try using this one, it's gonna be T4 equals to 4 into 4 minus 1. So here's gonna be 16, subtract 1, it's gonna be 15. So remember, now they were looking for the general term, which is this one. So in another case, if maybe they said to you, please try to find the maybe as any particular term in the sequence, let's say maybe T6 or T7 or T4, so you can just use this one instead of this one. So unless maybe in the previous video they told you that find the general formula, you know that you have to use it to find the next question. If not, you can basically just use this one. It's still the same thing. It's gonna lead you to the very same answer. Ne? So let's move to the next question. So fourth question, find the 100th term, T100. So T100, it's gonna be 4 into 100 minus 1. It's gonna be 400 minus 1. So it's gonna be 399. Ne? Let's try using that other one. A plus 99B. So remember, this 99 comes from 100 minus 1 because of it, n minus 1b. Ne? Just remember, if you are trying to look for the 200th term, it was gonna be 199d because of it was gonna be 200 minus 1 from n minus 1d, which is in the general formula. Ne? Let's just erase this quickly. So to check if this thing is gonna give us the same answer or not, let's just try to check. So we know that our A is 3 plus 99, D is 4. So let's try to use the calculator. 99 multiplied by 4, it's gonna give us 396 plus 3. It's gonna give us 399. So you can see whether you use the left one or the right one, it's still gonna give you the same thing. But I highly suggest that you use this one. Why? Because in the previous question they told us that we need to find the general formula. So which means, just to get straight to the point, you should use in that following question, you should just use that general formula that you found to try to solve the answer. Ne? So in a way, it's like you found something, you should just use it. In a way, I cannot buy a car today, then tomorrow when I'm going to work, I take a taxi, like, you know. So basically, it's something like that. So basically, just keep that in mind. So let's go to the next question. Which of the term in the sequence is equals to 79? So we don't know which term is it, but we know that this term is equals to, it will give us 79 whenever we try solving for it. So let's solve for n, the term. So now here it's gonna be 79 equals to the general formula. It was 4n minus 1. So let's try solving for n now. This one goes to the other side. 79 plus 1 is equals to 4n. So it's 80 equals to 4n. And now divide both sides by 4, and our answer will give us 20. That's wrong. So it's the 20th term. So we can try to check if whether it is correct or not correct. So say 4 into 20 minus 1 is going to give us 80 minus 1 is going to be 79. So we now know it's the 20th term. No, should be in capital letter. So we now know it's going to be T number 20, the 20th term. Ne? So don't forget, after doing all of this, you should just write it. It's the 20th term. If you just leave it like T n equals to 20, yeah, it seems incorrect. Ne? So just note that. So let's, for now, please go for water break. Just 1 minute water break, and then we come back for the second segment. Thank you. Welcome to the second segment of this video. So the second question says, determine the arithmetic sequence if the second term, so it's T2 equals to -1, and the 12th term is -13.5. So T12 is equals to -13.5. So now we should find the sequence, which means we should find the general formula, ne, of this whole sequence. Ne? So now, you still remember this? So we're gonna use them to try to find our A and D. Ne? So it's A plus 11D. So -1 equals to A plus D. Excuse me. So it's the first equation. Then the S is our second equation. So we can try to find the third equation. So third equation, let's just use this one. So in a way, we're just using simultaneous equation of those two equations. So take D to the other side. It's gonna give us minus. Now let's just take A. Yeah, let's just take A first. Minus A equals to D. So this is our third equation. So let's substitute our third equation into the second equation. Substitute the equation into the second equation. So it's gonna be A plus 11, -1, -A. So here just do factorizing. You know that the 12th term is -13.5. So A equals to, so A plus -11 minus 11A equals to -13.5. So like terms and like terms here, like term and like term here. So let's just do this. So here we know that we will have -13.5 plus 11 equals to A minus 11A is equals to -10A. So here, let's try using a calculator. Let's see. -11, -13.5 plus 11. So it gives us -5/2. Then -A, divide both sides by -A. negative 10, sorry, divided by negative 10, it gives us that a equals to 1 over 4. So it's now easy for us to find the constant difference if we have a. Ne? So we found the first one. So let's try to use this one. We can use any one of them. I just prefer this one. So T2, we know that it's equals to negative 1 equals to a plus d. So you take this one to the other side, it's gonna be negative 1 over 4, and we are gonna get that d is equals to negative 5 over 4. So we found our a, we found our d. So now it will be very easy for us to find the general sequence. So let's just substitute here. We know that our general sequence, let's just erase this whole thing here. It's just messy. So it's Tn equals to a plus negative 1 over d is negative 5 over 4. Then it's 1 over 4 here plus, okay, it will be negative 1 over 4n, since here we have a negative 5 over 4n. Firstly dealing with this, then it's gonna be positive 5 over 4. Then these two are like terms, it's 6 over 4. So minus 5n over 4 plus 6 over 4. Let's check if we did the right thing, we didn't do any mistakes. So let's try to find for the first term. Okay, let's just try to find the second term. Second term, so here we know it's gonna be, so yeah, it gives us that because of here it's gonna be negative 10 because of it's 2 multiplied by this one over 4 plus 6 over 4. So this will be negative 4 over 4, gives us negative 1. So see that we found the correct answer. So now if you may say, but since say I have or may have a different rule, so you can still use it. Let's try this another example of how we should have tackled this. So you could have just simply, instead of doing that long route, do this equation. We are gonna take these equations and find the difference between these two equations, so that we'll have one formula, ne? So it's gonna be like this. So let's say T12 subtract by T2, it's gonna be, we know that T2 it is a plus d equals to minus 1, and okay, let's just remove this. A plus d equals to minus 1, and T12 is a plus 11d equals to minus 13,5. So we just say this equation subtract this equation, so it's gonna be minus 13,5 subtract by negative 1 equals to a plus, okay, 11d subtract everything here. So here we are gonna get 12.5 when we subtract 1 or add 1. So when we add 1, we're gonna take the sign of a bigger number and subtract. So here you can see that this one and this one will cancel out whenever we remove the brackets. So they will cancel out. We're gonna be left with plus 11d minus d. So it's gonna give us 10d. So we just divide, and then d we are gonna get, let's use calculus. we are gonna get negative 5 over 4. So from here we just say, oh, okay, so it's a plus, so just solving for a plus, okay, a minus 5 over 4 equals to negative 1. Then we solve for a minus 5 over 4 equals to negative 1. Then you take this to the other side, it's gonna be a equals to minus 1 plus 5 over 4. Then we are gonna get so since it's gonna be 4 over 4 plus 5 over 4, so it's gonna be 5 minus 4 over 4, so it's gonna give us 1 over 4 as the answer. So you can see that we found A and D, both equations or both steps, they just work. So you just need to find the one that you are most familiar with and just use that one. Don't use both of them and the very same question. No, we just want one. So here it was just an example that whichever route you take to your destination, doesn't matter. Whether you travel by bus, whether you travel by train or car or a plane, doesn't matter. Only thing that matters is reaching the destination. So here let's just continue and wrap things up. So it's gonna be 1 over 4 plus n minus 1, and this thing here again is gonna give us negative 5 over 4n plus 5 over 4 plus 1 over 4. So you can see that it just takes us to the very same, takes us to the very same place that we started. So it was really nice doing this video with you. So if you have not yet subscribed, please do the right thing. Just subscribe now. Subscribe, and I enjoyed this lesson with you and hope you will be ready for the next lesson. So we're gonna do the next lesson. We're gonna try to do a past paper question paper, just tackling arithmetic sequences. So make sure